Hello, everyone, and welcome back to COBOL Fridays. Today we have Bob Jeffcott from Software AG. Thank you, Bob, for taking time on a Friday. And I realized it is actually the Friday before a long weekend. So, a special thank you for taking time to be with us. And Bob will be sharing with us on how to connect your COBOL applications with APIs. We are very interested to learn more about that. So, without further ado, take it away, Bob.
Thank you so much. I really appreciate it, and thank you everyone for being here today. Uh, I am Bob Jeffcott. I work with Software AG. We are a worldwide software company. We've been in business for 51 years now. So we've been around. We've been integrating in and out of mainframes for the past 3 decades. We have a presence in 70 different countries throughout the world. 5,000 employees, and I've been with Software AG for 24 years now. Currently, I work with our Software AG Government Solutions group, but I've worked on the mainframe integration for the past couple decades, and both in the commercial and government solutions sector. Today, we're going to talk about connecting your COBOL applications with APIs. We're going to talk about 3 different areas. We're going to talk about the why it's important to API enable your COBOL application, how that fits in with today's digital enterprise. We're going to talk about what exactly do we mean by APIs? What are the different types? What's emerging technologies? Talking a little bit about that capabilities that you might consider when you're talking about API enabling your COBOL applications. And then how? We'll talk about what are some of the best practices, what are some of the common issues we run into, what are some of the different ways that we can API enable those COBOL applications. So let's start off with the why. And I will tell you, I am a IBM mainframe evangelist. I will talk about it to anyone that will listen, and I will talk about API enabling your COBOL applications. I'm a big fan of that, big fan of the mainframe. So a lot of what you're going to hear about today, if you take nothing else away, it's why this is important and what to think about when you're thinking about API enabling your applications. There are challenges with the mainframes. We hear a lot about it, especially with COVID now. You're hearing a lot about what you hear antiquated mainframe systems. We hear that it's legacy code. We hear that it's outdated screens, that they're hard to understand, they're hard to utilize, they don't easily change. The data and the logic is siloed. It's hard to get to. We always hear about the high costs of the mainframe, as well as the workload concerns. You know, are we putting too much stuff on it? And really, we're talking about legacy systems in general, not just the mainframe. So I'm going to use that synonymously between legacy applications and the mainframe. But it could be AS400, it could be legacy systems in Unix and Windows. So I know that there are folks that code in Micro Focus COBOL and other Linux, Unix, COBOL flavors as well. So yeah, we do hear a lot about that. However, what we don't hear about, and this is where the evangelization comes in, these things are really critical to the enterprise. Typically, these are tailored business logic. That COBOL makes your enterprise different than its competitors. It's custom code built to your specific enterprise's needs. The data that's contained, and oftentimes it's decades worth of data, is a high value. It's the history of your company, of your organization. One of our customers in the Southeast, a utilities company, values their data so much, they actually put it as an asset on their books. They say that their data is worth millions and millions of dollars. And let's face it, it's critical and connected to your operations. Typically, if a mainframe goes down, it's a problem with the business. So there are a lot of benefits to your COBOL applications. They are valued. There are challenges, of course, and now we're going to look at what some of those, how to overcome some of those challenges. At one point in time, the IBM mainframe was the center of the universe. Everything consisted on the mainframe, but times changed. And the integration requirements evolved over time. Initially, there were those .NET, or actual back then Visual Basic, Java applications that needed information from the mainframe or would push information to the mainframe. Oftentimes, those were done through FTP processes, batch jobs, extractions, runs. Then along came the ERP packages, the SAPs, the PeopleSoft, the Oracle Financials. All of those systems came along that required integration to the mainframe. Typically, those were replacing components that were running on the mainframe, financial system, HR personnel, something that was a little bit more homogenized and was able to be utilized within an organization without really changing that organization's DNA. Now you see the emergence of cloud-based technologies, the CRMs, the case management systems of the world, and there's needs to integrate those with the mainframe. And now the emerging technology is not only cloud-based applications, but cloud-based capabilities, whether it be something like Amazon Web Service, blockchain, Google services. There's a whole host of things. All of these things are putting pressure on the mainframe to say, I need to communicate, and typically I need to communicate in real time using different methods. So we need to API enable our COBOL applications and kind of to participate in that digital enterprise. And pressure to become a digital enterprise is growing, even now more than ever, with COVID, with people working from home, with more customer self-service things. You see so much evolution with smartphone applications. I can now order, I can now pick up, I want to notify people that, hey, I'm here, come deliver my stuff to my car. So you're starting to see that pressure to incorporate that mainframe into those things. So you're starting to see that cloud transformations, new applications are being built. As we said, that digital user experience. You know, I want it and I want it now. I want information at my fingertips. You're starting to see more of the advanced data analytics, streaming data analytics, the emergence of what we call microservices, those flexible, scalable services that can be deployed. But ultimately, a lot of those need to rely on the IBM mainframe backend systems. And of course, we're starting to see IoT with smart devices. Just in the last month, I have got a smart scale, and I've got a smart dishwasher. So my dishwasher now talks to the internet. So we're starting to see those emerging technologies. And ultimately, we probably need to have that information talk back to our mainframe. For example, with the dishwasher, it sends information that, hey, I might be having a problem. That information can then be sent to the manufacturer that puts a ticket out on its mainframe. So again, lots of reasons for the APIs and why that mainframe needs to quickly and easily communicate to a variety of different outside forces. And this is my, I don't want to say pet peeve, but my pet project is if you take nothing else away from today, I want you to think outside the box. I know you hear that as a cliche. I'm not talking about that box. I'm talking about this box, the IBM Z mainframe. We talk a lot, when we think of APIs, we think of APIs calls coming into the mainframe. But I also want you to think about calls going out from the mainframe. There's a whole world of technology out there that you as a COBOL programmer can embrace. There are those cloud services and resources we talked about, something as simple as email or address verification. But there's a whole host of services that are out there, GIS interfaces, lots of different things that you can interface with. There are other APIs within your enterprise. There's a lot of valuable stuff that you can connect to from the mainframe. There are APIs outside of your enterprise, whether it be your vendors, whether it be your partners, those kinds of things. Think about connecting to those. Other applications and data sources, both within and external to your enterprise. And one I see that's growing a lot are message queues, the JMS, the publish and subscribe, called PubSub. Events happen within that mainframe in a variety of different places that people may or may not need to be notified of. So what you can do is send those events to those message queues so that people can subscribe and be notified of them. One of our state agencies has a notification system of their criminal justice system. So anytime within the state when someone gets released from jail or put into jail, they publish that information on a message queue so that various people can subscribe to that, whether it be notification of victims, whether it be something like a Health and Human Services service that can talk to get information that say, hey, this person's being released, they need rehab, let's do this in real time. So it's an easy way for you to publish out an event and not really have to worry about who the subscribers are. It's just out there for public information or for information. And there's also other emerging technologies like business rules engines and other capabilities, case management systems. One of the biggest complaints we heard about those antiquated COBOL systems was it was hard to change the rules, especially when it came to things like unemployment claims. So connecting to a business rules engine that an end user can then manipulate and change is a huge advantage, and then would be something that could be utilized to eliminate that perception that it's antiquated. So again, nothing else take from this is to start to think of things that you can utilize outside of your mainframe world, outside of your COBOL. And I'm going to share with you guys just two examples of those things, thinking outside the box. The first one was a state agency, that same state agency we were talking about that had criminal justice information. So they had a bunch of data out there in their own little siloed world. Another agency within that same state had a COBOL batch process that had absolutely nothing to do with Agency A. Agency A was a criminal justice system. Agency B's COBOL batch processing was a completely different division. Agency A's data, however, was in jail. And strangely enough, it was information about whether a citizen was currently a guest of the state in jail. But what they one day decided to do is they decided to free that data and create an API. So a very enterprising programmer in Agency B took their COBOL batch process, which was unemployment claims processing. They said, hey, I can utilize that API in my process. So according to the state's rules, if someone was in jail, they were not eligible for unemployment checks. So this enterprising programmer, without asking anyone's permission, incorporated that API into that batch process. From the time that programmer discovered it to the time it was implemented in production was less than 6 weeks. And that simple API, one simple API in your COBOL process, saved that state over $100 million in preventing fraudulent unemployment claims in just over a year. And since it was a state agency, I'm sure that programmer got a very nice certificate in appreciation for what they did. But again, just a simple small change made a huge impact. And then the second one that I wanted to talk about, again, was a very small change, but it was critical to this entity's enterprise. So Dole Foods, worldwide distributor of foods, has a mainframe application. I will be honest, it's not written in COBOL, it is written in natural, but the concepts are the same. They were approached by two of their customers, two little small customers, Walmart and Lidl Foods, which is a European food chain. They said, hey, we need you to integrate with IBM's blockchain. This is to facilitate product recalls. So before this, when a product recall was issued from Dole, it would take anywhere from days to weeks to track down where all that food went, where all that food needed to be pulled from. So because they used object-oriented programming, they updated one program in their mainframe supply chain application to interact with IBM's blockchain solution. This allowed for pallets to be tracked from source to table. And the guns that they use to track those barcodes are actually mainframe 3270 guns that feed the information back directly into the mainframe. So their recall process went from days and weeks to minutes. IBM called it the fastest blockchain implementation that they had ever seen. If Dole had not done this quickly, they may have lost Walmart and Lidl as customers, and obviously no one wants to lose Walmart as a customer. So again, a small API change was able to ensure that their business continuity would continue, that their revenue streams would continue. With that, I'm going to pause for just a second and see if we have any questions so far.
Not yet, Bob.
Okay.
This is riveting. This is riveting.
Thanks. Thanks. Okay, so now let's talk a little bit about what do we mean by an API? And I will give credit to my IBM partners for this part of it. I did a presentation at the Share conference, and we were going through all the different steps you would need to create an API, and someone stopped and asked, well, what exactly do you mean when you're saying API? So let's talk a little bit about that. This will be by no means a end-all be-all tutorial about REST, about SOAP, about the APIs, but we at least want to have a common understanding. You know, we started out, an API, we think of it as just a reusable service, exposing the business logic and data of an application. It started out with RPC, remote procedure calls, long ago. You know, you saw that in the VB world, the Java world. But we have a standardized capability defining what those RPCs are. SOAP was the first one. REST is now the emerging, more popular technology that you have. But those continue to evolve, continue to grow. You're starting to see things now like OData and GraphQL emerge as the next wave of technology. So I think that that's one of the things we want to make sure that when we API enable, we realize that the technologies that might be calling us or us calling out to are going to change over time. And I'm going to talk really right now just about the two capabilities that are kind of the de facto kings today, keeping in mind they might not be the kings tomorrow. So we have SOAP and REST. That's kind of what you're going to run into the most. SOAP stands for Simple Object Access Protocol. It communicates via XML, and it is indeed a protocol. It is a very defined, somewhat rigid API. It uses what we call a WSDL, a web service definition language, to describe what that SOAP service is. It describes the inputs, the outputs, the endpoint of where I'm going to communicate to. The advantage of SOAP is it's language platform transport independent. I can utilize it in a variety of different ways. There's a lot of extensibility in the form of web service standards. Challenge with it is, though, because it does do that, it does require more bandwidth. XML is a format where you tag all the data with tags to describe it, but because of that, it takes a while to parse. It takes some overhead. The emerging technology that, I shouldn't even call it emerging anymore, the technology that seems to be most popular today is the idea of REST. And that's what we're going to do in our demo today, is show you a REST. It stands for Representational State Transfer. It communicates in a variety of different formats. That's one of the nice things. It is flexible. I can do it with plain text. I can do it with XML, or XML, excuse me. I can do it with HTML. I can do it with JSON. JSON's a much lighter weight, much easier way to communicate, a little bit easier to understand. So it's an architectural pattern. There isn't a defined protocol. So one of the bonuses, it's accessed via HTTP. So it means it's TCP enabled. It's a little bit easier to use. Unlike SOAP that has a single defined standard, it can be described by a variety of different methods. Swagger document, a RAML document, or now a growing initiative is the Open API. This was originally a driver by mobile apps. Mobile apps, because of their nature, needed something simpler, something more lightweight than a SOAP call. So that's where really REST grew in popularity, is those mobile applications, those smartphone apps. And because they are more efficient, they can use smaller message formats, less data, etc., and is faster. So that's really the growing trend. So we're going to take a look at a little bit more about REST. Before we move on. So we talk about a REST resource. So again, we said it was HTTP driven. So resources can be coarsely or finely grained. And what we mean by that is one resource may just do a simple function, get employee, and that's it. That's all that REST resource does. Or it can be coarsely grained. It can be, and the example we're using here is a pet store, for the most part, a pet store example. So that one REST resource can contain multiple different functions within it. So I can get a pet by ID. I can do a pet by a find status. I can get the store information where I can place an order. So that's one REST resource, but it has a lot of different functions underneath it. And one of the things you'll see here is a separate example. So not only might I have a defined input, like this pet ID, or in this particular case, a flight ID and a passenger ID, but I can have some optional parameters as well. So a REST call can be very flexible. I may or may not send stuff to the calling resource. So that's something we'll talk a little bit about later, is how your coding has to be flexible. So for those resources, you have methods. So when you call that resource, you're going to also call it with a method. There are 5 standards today. The 5th one's actually pretty new. There's a get, which simply retrieves data, a post, which adds data. So typically think about it in the CRUD world, that's a create. A put replaces existing data. Now originally put was to replace or update existing data, but in reality, put is supposed to replace everything within a particular record, within a particular resource. Delete, obviously, deletes an existing one. And now patch was added to say, I want to do a partial update of existing data. So those are the 5 methods that we'll look at a little bit today. Some of the benefits of REST, like we talked about, it's HTTP driven, operates on TCP/IP, so it's ubiquitous, it's everywhere. It is lightweight. especially compared to SOAP. I don't have to parse out the messages with as much effort. Um, it's relatively easy development. I will tell you it is a bit overwhelming at first when you actually start to look at it, but not everything's required. And when you realize how flexible it is, it takes a little bit of time to understand, but not so much. And again, it's more common. That is becoming the de facto standard of exposing APIs and what we talk about a little bit with microservices, that idea of deploying out lightweight services to the world that are scalable. And something we're going to talk a little bit more about when we talk about COBOL coding considerations. It's stateless. So I make a single RPC call via REST that has no state. So I don't know anything that happened before that. So it's something that's an important consideration, and it is a strength, but also sometimes a challenge. So let's just talk about a couple of the common mainframe API use cases that we're seeing out there in the world today. Some things for y'all to think about. One of the challenges we hear about mainframe is it is siloed. You know, I might have multiple different functions within a mainframe, multiple different screens that do something in a business process, but I might need to expose that entire business process out, again, for maybe a smartphone, you know, mobile apps, those kinds of things. So I want to create multiple finely grained services, get customer info, process orders, and update inventory, and be able to publish that out as a single API. We see that a lot, especially as people are moving to more self-serve capabilities within the industries. We are starting to see, you know, a lot of things move either to the cloud or to other systems. So we want to orchestrate information from those other systems and the mainframe together. So that ability to have those communicate together, have those APIs put out to create a new capability for the business. And again, probably one of the older and more original and more important APIs that we see is that ability to integrate between the mainframe and other ERPs, whether it be the SAPs, the PeopleSofts, the systems. An event in one has to update the other and keep those in sync together. And then again, kind of like we talked about with Dole Foods, is that call out to external mainframe, external APIs from the mainframe. We're starting to see that more and more and more. So those are just some of the common ones. By no means is this a definitive list. And now before we move into our what, or how, excuse me, I'm going to pause again. Any questions?
Yes, Bob. Okay. The question is, are there any security issues similar to Java with RESTful API interface?
Yes, absolutely. And we are going to talk about that in the how. But I think the biggest consideration is that the people that are calling these APIs are typically not going to have mainframe security. So you have a disconnect between the two systems. Typically, that API is going to have some sort of security, whether it be a basic authentication, whether it be a token, whether it be a certificate, and then the mainframe is going to have its own, whether it's RACF, whether it's top secret, ACF2. It has its own mainframe requirements or security requirements, and there is going to be a challenge with how best to do that. And I will talk about that a little bit more here in the how part, if that's a fair enough stop. And
Sounds great. Yeah.
okay, all right.
Thank you, Bob.
No problem. But that was a great question because it is coming up. So let's just talk a little bit about how to connect, how to create those APIs. Absolutely, we can build it themselves. One of my favorite stories is Ducks Unlimited. They are a conservation organization based in Canada. They provide or they help to do wetland preservation. Their their president went to their CIO and said, "Hey, I need to put the mainframe out on the web. Oh, by the way, we're not buying any new software and we are not hiring any new people." They figured out a way to create an auction website leveraging their mainframe applications in a simple CGI program that would make a call to the mainframe. The mainframe would build the HTML and push that back through CGI. And they were up on the web. And this was in the 90s, so we're talking a long, early infant stages of the web. They were on that in, I think, about 8 months. So you can absolutely build it yourself. There are some pros to it. You can leverage those existing resources. The interfaces are typically built to your specific needs, your specific requirements, and it is an absolutely lower initial cost. But there are some challenges with that. Those resources and the knowledge that they have can leave. We have a customer who has an API that their entire business relies on between the mainframe and one of their other systems. And the person that wrote it not only left, but retired and moved to another continent. So if that API breaks, they're in trouble. We talked a little bit about this. Standards are constantly changing. I briefly mentioned OData as one of the new standards that you're seeing as an emerging API technology. While it is a new standard, they're actually on version 4 of OData standards. So they are constantly changing. It went from SOAP to REST. So you're going to have to, and that's where those unforeseen and hidden costs come in. It might be something that you're having excessive resources on your mainframe. You're having to rewrite things constantly to meet new demands. So there are some, there are some hidden and longer term costs that you might see. But we do have a lot of customers that are building these things themselves. You can utilize enabling software. And I did just pick the 2 biggest ones, our Software AG Web Methods platform and the IBM ZOS connection, our software that quickly and easily enables you to create APIs, either invoking the mainframe COBOL code or having the COBOL code invoke external APIs. So there are a host of other ones out there, but those are the 2 predominant ones we see today. Some pros: it meets those changing needs. It separates that API capability, that back-end COBOL API from whatever is going to be published out. I want to publish it as a SOAP. I want to publish it as a REST. I want to publish it as an OData. I can do that. The software typically keeps up with that. It removes a lot of the complexity, and we're going to talk a little bit about some of the complexity today. Simple things like EBCDIC to ASCII translation, tables, data type conflicts. It removes a lot of that complexity that you would have to build into your own solutions. And it's a supported product and has that, going back partially to the question, it has the built-in securities and can do some of that resolution conflict with that security. There are cons, of course. It is a higher upfront cost. It is introducing new technology. Might be things that you don't have those skill sets. And you are relying on that vendor, to keep up. You're relying on that vendor to support those products. So there are some challenges with that. And with that, I do think we do want to talk about some of the programming considerations and best practices. And we'll talk a little bit about security as well as some of those other challenges you're going to see. And we're going to talk about it in 3 different areas. We're going to talk about it first as COBOL programs as a server. They're the called API. So the first thing Callable objects, your COBOL code, when you're writing it, you have to be considered stateless. That means that I'm going to have a call. I can't rely on any previous information. I can't rely on anything that happened before. APIs are traditionally stateless. And yes, if you want to be picky about it, there are stateful APIs. Those have special use cases, and they are certainly not as flexible, but yes, there can be stateful APIs. So this is not a hard and fast rule, but it's something I think that's important. Security concerns. As we talked, as see, it was in here. Invoking APIs likely aren't going to have mainframe security credentials or pass tickets, and that's one of the things we're starting to see on mainframes. You know, there's technology now that requires a one-time pass ticket, and then becomes invalidated, or your security password changes every 5 minutes. You know, for you and I, that's not a big deal. I log into the mainframe in the beginning of the day, and I stay logged in all day long. But when we talk about those stateless APIs, they're logging in each time. So that can be a challenge. So you have to make sure that there's some way you can address those challenges. Also, often you want to know who that person was that did those updates or got that data, you know. So you need to make sure that there is a way to track that without adding the entire world into your mainframe security systems. We want to make sure that your programs are multi-purpose. APIs are typically, there's going to be a multitude of APIs. It might have a different audience. There might be a public API and might be a private API that make the same call. They may return different data. You know, an internal person can see everything about a customer. The external customer can only see their relevant information that they may be able to change. So you want to make those programs multi-purposed as much as possible. I want to make them flexible. As we saw with the JSON example with the REST service, I may pass 1 parameter, I may pass 10 parameters. So you need to make sure that your program is aware of that it needs to be that flexible. So I don't have to write 10 programs to address 10 different APIs. I can reuse that single program for one API, or multiple APIs, excuse me. Make your programs object-oriented. That's what the strength of Dole, why they were able to do it. If you're going to do an update, if you're going to have a business rule, make it one callable object. That's good practice for both APIs and just programming in general. So you don't want to have to rebuild multiple versions of something. And kind of along with that, when you're talking about an API, you don't want to have inputs. You don't want to have input-outputs where there's a screen, because it just doesn't typically play nicely with that. You know, you can get around it, but there's ways where you have to populate input data so that you get past those screens. It's not the most friendly thing in the world. COBOL is a client. So if I'm calling out from COBOL as a client where I'm calling out, typically the structure of that calling of the API that's being called isn't structured. I may or may not return all the fields. Arrays might be boundless. If I say return me all the customers, it might return 1 million customers. So you got to be prepared for that. You have to be able to realize that, like if I'm going to use structure, if I'm going to use a fixed array, that I have to be able to I have to be flexible enough to either maybe go make the call a second time with a continuation or something along those lines. Security mechanisms are different. Again, what we talked about is you may need a separate form of authentication. It may require a token. It may require a certificate. So you're going to have to be aware of those. And when you're starting to talk about batch, and that was one of the challenges with that example that we used, latency may be an issue. And again, one of the reasons why REST is winning out over SOAP is that it's just faster. So, you know, you have to worry about potentially some timing when you make that call. Is that service available? Now I'm making a call that's, Paul pointed out earlier, my example that airline URL is no longer available. So, you know, when you make a call out, that resource may not be there, so you need to allow for that. And then just general considerations. Typically, when we think about the linkage section of a COBOL program, everything's input and output for the most part. I mean, we can do it the other way, but inputs and outputs are different. I want to, you know, what I'm going to call, they're expecting a simple input and potentially a more flexible output. And again, that boundaries don't exist in arrays. So some things that we don't ever think about, like if we're putting out an array and it has a numeric field in it, you may want to use the blank when zero clause, because if it's a 0 and I have an array of 100 instances, it's going to fill that out and return all 100 to that call. So there can be other issues like with EBCDIC ASCII. Again, typically a tool will get around that, but sometimes you have challenges with the characters that you send don't translate correctly. So just some general considerations. And lastly, this really isn't really on the mainframe part, but if you build these APIs, a lot of times people will utilize them heavily. So we want to talk a little bit about API governance, and again, that's more with your, you know, the people that are actually going to be publishing out these APIs, but things to think about. The security, like we talked about, you may not have a mainframe user ID. You might have certain SLAs that you have to meet, and then policy enforcement. Not everyone is treated the same for those APIs. You really want to be concerned about logging to make sure you can match what was called with what happened on the back end. And you do want to look, again, this is kind of outside of the mainframe, but throttling. You know, we had a customer that published out an API on their web page, and it got hit by web crawlers. So they went from thousands of hits on their mainframe an hour to millions of hits that they were not expecting. So one of the ways around that was data caching. Make sure that that data that's highly accessible, that's accessed often, is potentially cached. And then lastly, just worrying about versioning, and then the ability to hide your backend, that virtualization of that endpoint of the mainframe, so that it can't be seen from the outside world. Again, a little bit more outside the mainframe, but things to think about when you're talking with the people that are going to be publishing those APIs outside the mainframe world. With that, I'm going to pop into a demo, but before the demo, and can we pause one more time? Any questions?
Paul, did you want to bring up the question about a reason to perhaps switch from a SOAP to REST, or
Yes.
do you want to do that after the demo?
I can do that pretty quickly right now, because there was a follow-on question to it too. Let me ask the follow-on question first. Bert asked, does the WSDL port to COBOL?
It can, absolutely. And that goes back to the tools, the COS connection, and the software AG tool will translate that WSDL into COBOL language.
Okay.
Absolutely. You can do it yourself as well. Again, there's a lot of tools with that that can interpret that WSDL, and you could do the translation with that. So yeah, it absolutely can. There are some considerations with that though. Like we said, XML SOAP is limited in the types of data fields that they have, but it's unlimited in the amount of data that they could have. So, you know, COBOL typically likes to have things defined in advance. So there is some challenges with that, where a field may be longer than you're expecting, or there may be more occurrences of an array. than you're expecting.
Yeah. And one thing that I did, Bob, I posted a question, but I think you answered part of it. So given I have a SOAP WSDL solution, is there any compelling reason to change my design to be REST JSON? And I believe speed was one of them, flexibility. I think I heard that afterwards. But then I asked a follow-on question, would the design change from SOAP WSDL be easy or somewhat time consuming?
So actually, you can, and I have to admit, I'm not the expert in this, but I have utilized it. So you can use a SOAP service as a REST call. So you could do that. Now, you don't gain the benefits of that, the speed and those kinds of things. But to answer another thing to answer your first question is it depends upon the audience. Typically, the client is the one that decides, hey, look, I need to communicate in REST. For example, Salesforce uses SOAP. So that's great. If one day for their interfaces, they said, we're going to change this all to REST, it's probably going to be more beneficial to do the REST. So it really is the demand of the client.
Perfect. Yeah, that answers it. Thank you, Bob.
Okay, great. So we're going to do a quick demo with the Software AG Web Methods solution so we can actually take a look at some COBOL code, look at some of those programming considerations that we talked about. It's going to be a simple COBOL program called Apple. Two functions within that, two capabilities. It lists the employees and it gets an employee's details. What we're going to do is we're going to publish that out as a REST resource with two operations, two functions, list employees and get employee details. We're going to use a tool called Postman. It's an API development tool. It's free. It's out there. It helps you build, test, and modify APIs. So there's two tools that I like to use. Postman is one. It's great for REST APIs. And then SOAP UI does both SOAP and REST, both shareware software, both easily accessible. So we're going to go ahead, we're going to jump into this and do a very quick demo. So we have some time left to do some talking. So I'm going to bounce into our IDE. It's our Software AG Designer. It is Eclipse-based, so it's the same development platform that was originally created for Java. It just has different plugins. And for this particular one, we are going to have a little project here. It's called Demo COBOL Fridays. We're going to create and do a query. We use the concept of an IDL, Interface Definition Language. It does that resolution between COBOL and the outside world. So we're going to use an IDL extractor for COBOL. We're going to talk to our particular COBOL environment. And here, let me actually take a step back and walk you guys through our extraction environment. So we just have an extractor that communicates directly with our mainframe. We have the ability to utilize a variety of different services. I really should have talked a little bit more about this. Today we're going to communicate with the COM area, but that has that 32K limit. But we can also talk to channel containers, same thing for any API. So when you're starting to talk about larger data sets, but within CICS, you can utilize channel containers, you can utilize sockets, or you can use a batch linkage section if it's not CICS dependent. But for this one, we're just using the simple thing. We specify where our mainframe is, what service we're calling, and my credentials. But most importantly, we're actually going to query a particular data set where my COBOL source lives. And with that we're going to query that data source. I have 3 programs out there. The one we're going to utilize is that Apple. So again, I can specify how I want to communicate to that. I'm going to communicate that my input message is the same as my output message at this level. I'm going to do a next. Okay, so now we're looking at the code. We're looking at, here's all the code, but here is our communication area. This particular one has a level 88 field, so it has, it has options that I can set with a predefined value. So in this particular case, what we're going to do is we're going to take what the COBOL looks like, and then we're going to say this is what we would like it to appear as that API. So the first thing I want to do is I'm going to set a constant for that operation. So the operation has two options, either list or details. So I'm going to go with list. It has an employee ID. We defined that originally as input, everything again, input and output, just typical. But you know what? Since I'm just listing employees, there's no input, so I'm going to suppress that out. Same thing for details. I'm going to suppress that out. So now I just have my output, and I'm going to make that just out only. Out only. Oh, sorry, I want to suppress the employee details. So the employee list is going to be out only. But we talked about that there's really two different capabilities within this program. So what I'm going to do is I'm going to create a second interface. So my second interface, I'm going to set that constant to get employee details. I'm going to make that employee ID, map it to input only. The employee details, I'm going to map to output, and then I'm going to suppress the list. Okay, but again, what I code in COBOL may not be as friendly to that API. So one of the things we do is we have the details as a pick 100 list. So it's a 100 bytes of stuff pushed together. I want to suppress that. I don't want to see that, but I've redefined it. So on that redefine, I'm going to say, let's map it to out. So now I have something that looks very different. I have one input, this one output. So now I have two capabilities. Both the list employees and the get details. I'm going to say finish. So now I have this IDL here with the program emp apple, which is pretty ugly, but I'm limited to my 8 characters. But what I'm going to do is I'm going to give that a much more user-friendly name. So I'm going to say this is called list employees. And the employee apple, let's call that employee details. So now I have this IDL that tells me what my COBOL looks like and what my output's going to look like. Now from here I can just simply go and do a quick test. Oh, I got to save it first. Do a quick test here just to make sure I can communicate back to the mainframe. So I have this mainframe connection that I've established, and I'm going to say it's COBOL, and my server is called COBOL CICS. Quick ping says, yep, it's up and running. I'm going to do a call. So now what I've decided is I can make a call to the mainframe through an API. Now let's build that out as a REST service. We just use our integration, our web methods platform to publish out those REST services. We tell it which one we want to communicate to. And we have already set up a connection here. So we've defined that connection to say I want to communicate to this mainframe over this port. So we already did that. But what we're saying is I want to create or update a REST resource. And I'm going to come in here. And I am going to do my demo employee Fridays. And I'm going to update one because I did cheat and say, oh, let's add this one. Make it Friday resource. So I'm going to publish that out. I'm going to go over to the web methods REST platform here, and you will see I got to do a refresh. In my demo, I have this REST resource now that's out there in callable, employee resource. And now when it generates this, it doesn't know what type of methods. So I'm just going to change that really quickly to a get only, because, again, it could be, it doesn't know what the COBOL program's doing. So I'm going to change that here. Save it. And then, we talked about describing it. We use Swagger for our stuff. So we're going to create a document to describe this REST resource now. Okay, it's a provider. And we talked a little bit about the formats that it can accept. It can accept JSON and XML. And I want to use that employee resource. And so now I have that Swagger document that describes what that resource is. I was going to import it. I know we're running out of time here. So what I'm going to do is just bounce over to our Postman, just so we can talk about a couple things very quickly. So I'm going to utilize something that's already out there. This list employees. So a couple things going back to the authorization piece. So that REST resource needed an authorization. Inherit from parent. So if we look at it, there's a bunch of different authorizations you can do. I'm going to do a basic auth. This is passing the credentials, not of the mainframe, but of the published out service. And then at the header section, I can tell it what format I want to use. So let's first just do a simple send here. It's probably going to time out. So it returned those services in a text, in an HTML format, but I can say, you know what, that's kind of ugly. So we're going to say we want to accept it in a JSON format, which is a little bit more user-friendly. So this just talks about the flexibility, see, a little bit more friendly format. So with that, I know that was really quick, but I didn't want to go over on time. I think we can just bounce back and see if there's any questions. Any follow-up questions?
Yeah, so Darshna, if you want to, I'll go ahead and get started. Well, Bob, you did a great job of selling the product, because here's the questions. So someone said, hi, Bob, is Software AG IDE open source, or is there a free trial version, like a community edition?
And there is absolutely a free trial edition. You can go to our website, softwareag.com/mainframe actually, but there are trial downloads for all of that stuff.
Very good. And then go ahead, Bob.
Yeah.
No, I was going to say, as much as I love our stuff, there are, we're just one of, but yeah.
Yeah. And so another comment question. Nice extractor API, Bob. Does that set up ODBC for SQL access like DB2 there?
It does not. Again, that was a COBOL. So there are a host of tools out there. And again, that could be a whole nother topic of data access versus code access. But this particular one, and I think I personally, again, advocate when possible. And again, it's not a hard and fast rule. I like executing the business logic, because that is your differentiator. The data that's stored underneath does not always necessarily reflect the end state that it wants to be published as.
Okay, and Sudarshan, I'll turn it back over to you. I don't see any other questions unless you do.
No, that's it, right? Thank you, Paul. Yeah. I just want to put in a plug here for our upcoming IBM Z Day, which is going to be on Tuesday, September 15th from 8 a.m. Eastern to 4 p.m. Eastern. It's a free 1 day virtual conference, all things IBM Z. So do register. I'm sharing the link right here in our chat. And so we sure hope to see you there as well. Another opportunity to really see the power of the mainframe, like Bob said earlier, right? He's all for the mainframe platform. So hopefully we can share that enthusiasm and the power of the mainframe through that conference, and look forward to having you there. And I see, Bob, you are going to be having a session on share as well on September 22nd. Look forward to that informative session too.
Thank you. Thanks. Yeah, and for those that don't know, Share is virtual starting on the 22nd.
Yes.
So if you can attend, it's a great event, great organization.
Absolutely, absolutely, yes. And so, thank you everyone for being here today. If it's a long weekend for you, have safe long weekend and enjoy the weekend. Thank you again, Bob, for being here with us this Friday morning and sharing your expertise in this space. It was extremely informative and very riveting. I learned a lot about APIs and why. All right. Thanks, everybody. Have a wonderful Friday and take care. Bye.
Take care. Bye bye.